stars of Tatu-V. Dear friends, when we mention stars, we often think of super heavy gas spheres. But not all of them are enormous in size. In fact, within our Milky Way, there are also very small stars. One of them is the star EBLMJO 555-57 AB. This is a red dwarf in a triple star system, located about 600 light-years from Earth. After its discovery, scientists measured this star to be smaller than Jupiter. It seems to have just enough mass and size to sustain nuclear fusion in its core, allowing it to be a star. Our Jupiter is also primarily composed of hydrogen and helium. So why, with such a large size, can it not become a star? Let's join Tatu-V to find the answer in today.
Enjoy watching the video. Don't forget to subscribe to Oddity Odyssey and turn on notifications to always.
Now, let's explore together. A star is an astronomical object, a massive sphere of plasma tightly bound by gravity. For most of its active life, a star shines due to the fusion of hydrogen into helium in its core. This energy is released from the core to the star's surface and then radiates into space, allowing us to observe stars hundreds, even tens of thousands of light years away from Earth. From Earth, the closest star to us is the Sun. It is an almost perfect plasma sphere, heated to incandescence by nuclear fusion reactions in its core. The Sun primarily emits visible light and infrared radiation, the most crucial energy source for life on Earth. With a diameter of about 1.39 million kilometers, it is roughly 109 times the size of Earth.
But in terms of mass, it is determined to be about 330,000 times the mass of Earth. With this mass, it accounts for about 99.86% of the total mass of the solar system. This is truly a very large and heavy sphere, isn't it, everyone?
In our solar system, besides the Sun, we know of another giant object, which is Jupiter. With an average radius of about 69,911 kilometers, it is about 11 times the radius of Earth. With this size, we could fit 1,321 Earths inside Jupiter.
This is indeed a super large size, isn't it, everyone?
It is even larger than some stars we have observed in the universe.
For example, the star EBLMJO 555-57 AB, 600 light-years from Earth.
It has a radius only about 84% that of Jupiter. On the other hand, Jupiter's composition is mainly hydrogen and helium, similar to the material in a star. Did Jupiter become a star? Before the 1990s, many scientists believed Jupiter could be a failed star. And many hoped it would become a star in the future. In that year, when NASA's Galileo spacecraft flew to Jupiter, many worried that the spacecraft's plutonium fusion reaction would explode,
providing energy to ignite the gas stream on Jupiter,
triggering a chain reaction that could turn the planet into a star.
But in reality, when the spacecraft crashed into Jupiter, the impact did not ignite hydrogen or cause an explosion.
The main reason for this may be that Jupiter lacks oxygen or water to support combustion. And since then, it has been believed that Jupiter cannot become a star. The data Galileo sent back to Earth gave us a more accurate understanding of Jupiter. One major reason Jupiter cannot become a star is its mass. Although very large in size, Jupiter's mass is only about 318 times that of Earth. With this mass, it is insufficient to initiate nuclear fusion. For example,
with the star EBLMJO 555-57 AB mentioned earlier,
although its radius is only about 84% of Jupiter's, its mass is about 85 times that of Jupiter. This shows that to sustain nuclear fusion in the core, stars need a great deal of mass. Scientists estimate that for Jupiter to undergo fusion, it would need a mass 75 times its current one. This means that to become a star, Jupiter would need 75 times its current mass. And all that mass must be compressed into its current size for Jupiter to qualify for hydrogen fusion into helium. Therefore,
Jupiter certainly has no chance of becoming a star because it doesn't have enough mass.
but even if a miracle provided enough mass for Jupiter, it still might not become a star. The reason is that Jupiter is destined to be a planet. This may sound like a predetermined arrangement, but it's the truth. Jupiter formed from a protoplanetary disk, which is the leftover material after the Sun formed. So, Jupiter is merely the result of dust and gas accretion, and its core lacks sufficient energy to trigger nuclear fusion. Most scientists today believe that Jupiter has a diffuse core. S core has a radius of about 0.3 to 0.5 times Earth, and contains mainly heavy elements. Therefore, it seems unable to trigger nuclear fusion even if provided with enough mass. Meanwhile, stars form from the collapse of giant molecular clouds, where the gravitational force and internal pressure are great enough to trigger nuclear fusion at the center. Thus, Jupiter will forever remain just a planet. Perhaps that is the law of nature. Although Jupiter will never become a star, it is the largest planet in the solar system. For Earth, Jupiter plays a very important role. Many scientists consider Jupiter as a shield protecting life on Earth, helping Earth avoid collisions with asteroids and comets from space, especially long-period comets. When they fly into the solar system, Jupiter's immense gravitational force pushes them out of the system before they approach Earth. However, some other scientists argue that Jupiter's nature is two-sided.
On one hand, it can push long-period comets out of the solar system.
This enormous gravitational force holds objects in the asteroid belt between Mars and Jupiter. Sometimes Jupiter's gravity is likened to a slingshot, pushing objects from the asteroid belt toward Earth, threatening life. To this day, scientists still debate this issue. Is Jupiter a shield protecting Earth or a catalyst pushing objects from the asteroid belt? Each viewpoint has its own evidence, and the debate has never cooled down. What about you? Do you think Jupiter is Earth's guardian or a saboteur? Please leave a comment below the video to share your opinion with everyone. Jupiter can never become a star, that's for certain. Perhaps this is nature's arrangement that we cannot change. This ensures we only see one sun when standing on Earth, and that is the immutable order of the solar system. So today, Ta2V and you have together answered the question of why Jupiter cannot become a star.
Wishing you all an enjoyable video view.
Now, please choose the video on the left or right of the screen to explore other mysteries of the universe with Ta2V. Looking forward to seeing you in the next video.
Goodbye.
Subscribe to the Gian Migo channel so you don't miss exciting videos.